All right. So we've got a couple new things that we're going to try because of some of the projects that we have coming up. We need to, now that we've kind of gotten some fundamentals together of how to operate and run in these different kinds of environments, these different programs. We've done some simple math. We've talked a little bit about the fundamentals of matrices and some of the MATLAB operations. We can start working on using something that is an immensely helpful project. So we're going to come here to the apps tab, and we're going to use the app designer. We're going to tell it we want to design an app, and they have some examples. We're going to start with an example that has some inputs. We're going to do a 2-panel as just an example, and we're going to do some manipulation of this so that we can see how this stuff works. Okay, so a simple 2-panel, and here's what we're trying to do. Here's what we're trying to do. We're trying to include some user input on the left. So we need some sort of, we need usually something like a, we might need a slider. We might need a label for what this is doing. We can change the label on this, but we might need a label for what this is supposed to do. We might need a numeric field to enter. And we might need a push button to make it all work. We might also need a drop down for selecting some options. So this will just give us some ideas. Maybe the label is going to come up here, and this whole process of doing what's called graphic user interface, this is something that has been made unbelievably easier by their approach here. So they'll let you switch back and forth between the design view and the code view. We're going to save this as an example in MATLAB, usually under documents. Again, this is why you want to be really particular. So test app 1. The apps, so long as your naming makes sense, you have a little bit of flexibility, but again, use underscores in the names for programs for MATLAB rather than spaces, because don't ask questions you don't want the answer to. So we can give ourselves a little more room here. So this is the user input side. I can zoom in a little bit, but I can kind of only get you guys so much here. Make it maybe a few % easier to see. Okay, so the drop down, this is going to be something like select. So we're going to go in and we're going to have some options. We're going to actually edit those on the code side. All right, so the key operations here, you want to make sure that you're saving early, saving often. We're going to go over the code view and look at what this looks like. We are going to include a plot for our output. They also have switches and some other things. We're not going to use that in this first example, but we are going to have a plot. Go. All right. All the interruptions today. Trying, guys. Trying my best. So we're going to look at the code side. We're going to include a plot. Here, it's a little hard to change the title and some things. You can do it here in the code. This is some of what the code includes. There's a bunch of different functions. So we're going to look at the code side in just a minute. But this will at least give you an idea of what's happening here. So you can change it to be resultant or something like that, right? You can change a little bit about some of the details. So we'll get into what does the code view look like. All right, so you save that. You jump over to code view. So this is going to show you a snapshot of what your app layout's going to look like. So you can jump back and forth, and it's going to allow you to do a lot of things. So it's defining a class, setting up an app, does all this stuff in the background for you, sets up containers and controls and labels and things, and it collapses that now in the more recent versions so that as much stuff is condensed as possible that you don't have to mess with, including things like setting variables for panel width and placement on the interface and where which pixel by which pixel everything goes. This is all important to how this stuff operates, how it gets laid out. This is all some of the details about the row height and column width and all this stuff, and what's all of the app layout things. So there's a bunch of stuff being done there, creating components for the app, positions in the window, all of those sorts of things. A lot of stuff that goes on in the background. So again, please appreciate just how much this is doing for you in terms of allowing for graphic user interface creation. This had to all be done line by line by line by line by hand. So when professors would hand us an example of we want a graphic user interface to do this thing, you knew that you were going to be up for 3 or 4 nights in a row doing this homework. You guys don't have that. You are benefiting from the charity of others in a tremendous way. So please understand that. All right. There's a bunch of things that are happening in these. There's a bunch of code that happens in order to just set stuff up. So the code doesn't do anything yet, but that graphic user interface, 155 lines just to create that picture without it actually even doing anything yet. So there's a couple things that we're going to drop some code into, and I'm going to show you here in just a minute what that looks like and how that all works, because of how much and where we need to do things. So there's going to be callbacks and functions and properties, and so they've got some examples here of how to do this. So we're going to talk about what some of each of those are here in just a couple of minutes. So a couple quick definitional things before we get into actually writing this. We're going to switch back over to design view to explain this. Each of these, as we select them here, for instance, you have an app button, you have the text, you have the slider. There are going to be callbacks, and what these are these are functions. We're going to have to write these functions in order to tell these things what to do. Take the edit field and multiply by the number selected from the drop down, and then use this range in the slider for the exponent or something like that, and then plot the results when we hit this, which is going to be plot the result. So you can include some information about what's being done, about the approximate equation, and things like that. And so maybe we use result is select number, maybe it's select number plus we'll call it multiplier raised to the slider value. So this is our multiplier. So we're going to put in some different options. We're going to add a multiplier, and then we're going to use a slider, and that's going to change what our plot looks like. So in this, maybe we hit let's see. Yeah, so maybe we leave that. But anyway, you can use something like a label to describe the equation. I'm going to leave that off for now. You end up with some strange things when you start doing some resizing sometimes. I'm not going to get into why that is right now. This is an extremely helpful app, so I'll leave it alone and avoid criticisms because it's immensely helpful. So we're going to have to add callbacks, and we're going to do that by this function, and we're going to do so each of these, it's not going to be to the test app. It's going to be, for instance, it's going to be to the slider, and so we'll talk a little bit about, for instance, like how we use these. So there's all of these things. I'm going to make sure this is multiplier slider value. I'm going to say base number, change our multiplier, change our slider. So we could say exponent, make it more clear what it is that we're doing. Okay. Like that. Something like that. All right. So what we're going to do is we're going to step into the actual setup of the callbacks next. So I got to get that prepped real quick. All right. So the callbacks, I wanted to start back on this screen to clearly articulate what's happening for each of these. What we're going to do is, for the things that we're doing in the left panel, there's a couple of steps. Remember, we've talked about differences between some variable types and whether they're local or public. And I tried to use the local and public language specifically because up here you can see properties access. This is general stuff that all of the functions that we write down below can have access to. So stuff that has to do with the button, the label, the slider, the panel, the axis, the figure, all of those things. So right now, methods is what the code's actually doing. So it's got these functions, and so it's this is where our callbacks will go. But instead of just writing stuff, you can't type in any of this code, and you can't edit it. And that's actually done on purpose so that you don't mess things up when you're doing app designing. So again, levels and levels and levels and levels and levels of like bowling bumper rails that are around you guys to make it simple. So when we go to do this and we want to say a plot result, all right, this is going to be a function, and this is going to call to the plot to actually present our information. So we're going to add a push button function callback. And this is what that's going to look like. So it's going to allow you to use, and it's going to suggest things that we need to do in order to get a value for the plot push button results. It's suggesting a couple of options. So this is really when we push the button, the main thing that we need to do is one of these two. We're not going to be setting the value. We're going to be getting the slider value. So it's suggesting, and this is where we can edit our code. So we want to get a value, and we want to store that to exponent. Equals app.slider value get. This is getting the app.slider value. So if we were to run this code, and I did this here, you could output effectively to like the command window, you could output exponent. But exponent, you can see this variable, there's a value assigned to a variable that might not be used. So we're not using exponent anywhere else. That's okay. We need to get the slider value. We also need to get our multiplier value. Okay. So that's going to be, from, yeah, so slider value, we're going to need to get our information from the base number drop down as well. So this is the drop down value. So we're going to say just above this so that we're doing it sort of sequentially. Base equal, and this is going to be app dot, and it's going to suggest some options. So we're going to do the base number drop down. And so base number drop down and dot value to get the value. So we're going to rewrite this one to be, this is also a get. So we're going to get a value. So this I'm going to rewrite to be, and I'm going to suppress this because I know what this is going to get for me. App dot. For the exponent, we're going to do exponent slider. So we're not looking for the label, but we're looking for the slider, that field. And we're going to get the value. There's lots of other stuff that we could be grabbing. We're going to continue grabbing our information. So we get the base, we get the exponent, we need the multiplier equal app dot, and we find the multiplier. So the numeric field, we don't want the label, we want the numeric field dot value. So we get the three values for these when we push the button. We don't need to, for right now, do individual callbacks for the other inputs. We're just going to use these for now. If we wanted to access these variables outside of the button pushed function, if we wanted to have two different button push functions, and one was graph the data, and then another one was graph the data with smoothing first degree or whatever. The second one would need to access the same information that we store. So we would need to create properties just like what you would see here. You would say properties, and you would add a new one here, add a property, and it would show up here with another section, and you could do a property and description. We're not going to do that right now because we don't need this for another button function. I'm trying to keep this example as simple as reasonably possible so that we can see what happens. So now we need to do some maths. So this is where our equation is going to go. All of this is going to happen when there is a button push event happening. So when we push the button, after we've changed our numbers, every time we push the button, this is all the stuff that's going to happen between function and end. This is all the stuff that's going to happen. So we need to do our calculation. Base times multiplier raised to the exponent. Raised to the exponent. So now we're using it. And we're going to suppress that. I'm actually going to switch the I'm going to switch the plot out, since I'm not doing an array and we're not building an array, and I'm not doing nested for loops and functions and fancy dancy stuff yet. I'm actually going to pause here in order to go back and make an edit, because I want a result, but the way that I want to demonstrate a result, I'm actually just going to use a semicircular gauge. No, I'm going to use a circular gauge for this. And it will automatically scale. Or it, I think, no, I don't think they automatically scale. Yeah, limits. Exponent, I'm going to do limits 0 and 3. Zero and 3. Yes, 0 and 3. So this way I keep the exponents reasonable. So the limits I'm going to do for the option. Let's see. Option 1. Maybe I'm going to simplify this down and do, because I forget, you have 4 options to pick from. So the value we're going to change to 1. Must be an element defined in the properties. So I think this is going to complicate life. So let me switch it I'm going to switch it for a spinner. Because this, I can have, I'm going to have limits of 0 and 10 as the base. So it's going to spin between 0 and 10. So this is essentially randomly generating a number between the range that I've specified. So this is going to be a little clearer. And I'm going to say this is the base number. So it's going to update the name. So I have to go change the code view. And this is going to be, rather than the base number, I'm going to start typing base spinner. So base spinner. What this is going to do is still allow us to pull a numeric value from base, a numeric value from multiplier, a numeric value from exponent, and do this math at the bottom, base times multiplier raised to the exponent. This will give us a range, and we'll see it output on the gauge. That's going to be the next thing, is we're going to say result. So we're going to store this. Result equals. Now we're going to do a set by way of app dot gauge dot value, and this is how we're going to set the value equal. So we're just calling it gauge right now. I'm going to update that name before we finish this. I'm going to update that name to result. And I think I'm going to need to set this limit a little higher to 1,000, and it'll rescale things. That way I can get a sense of how big things are. Because we're going to be dealing with numbers in that kind of zone. So code view, we're going to go back to, and we're going to store. We're going to store result to this. And I'm going to do a test run of this to see if it has any definition issues. So it'll come up with our slider. We're going to say our base. Okay, so this is not randomly generating quite as I had hoped. So we're going to say 2 times 2 to the 0.5 plot results. So we get a 2 there. We're going to do to the third there. We're going to multiply 2 times 5 plot result. So this is an up counter. That's right. That's what the spinner function is it's an up counter. Plot the result. So it's giving us an output of the function based on how these things operate. So I want to make sure that you guys are able to see, in a fairly simple example with multiple different inputs, the code operates as soon as we as soon as we operate. So anything above 1,000 out of range is going to show up there. There's a lot of things that you can do with these. This is just a really super bare bones, simple example of an input and an output. Now we can do array kinds of operations, and maybe that's what we'll do a conversion to next, is doing array operations, build them within a for loop or a while loop or something like that. Doing some operation to use this as a number of cycles that it does, or whatever the case is. There's a lot of things that go into these concepts for user interface, that you can do a lot of interesting things and display results in interesting ways, and the code works the same as it does in a normal sketch. You just have App Designer is a much more complex sketch. So sometimes it's easier to troubleshoot this same exact code in a sketch, but you can't do it with the you can't do it with all of this. So you can't do it with the sliders and other things. But if you're having trouble ironing out, like, oh, the data's not plotting the way that I want it to, or whatever, sometimes it's easier to just take some of that data array, manually copy it over, solve some of this in a simple sketch just for that piece, and plot an example data set and make sure it does what you want, iron out all of the shapes and geometries and sizes and whatever you're using to plot the results, and then take that code and bring it back into this block in the App Designer. So there's a lot of cool stuff that you can do, but this is a first tier, very simple, very basic, get you functional and operating in the MATLAB app builder, because it's, or the App Designer, because it's really, really useful and saves you tons of time and overhead. So there's so many hundreds of hours of work you guys won't have to do because of this App Designer. It's ridiculous. So, all right. That gives us at least the intro to a simple example. We're going to make some changes. So I'm going to start setting that up real quick. I'm going to lay some other stuff out so that we can make some changes on how this operates and what it's actually going to be doing. All right, let's start working on altering our setup here. So I'm going to remove the base and do this is going to be the increment. This is going to be the starting value. So edit field numeric. So starting value. Starting value increment. Okay, starting value. There we go. Increment, and then the exponent. So we're going to allow for the exponent on the function that we're going to put in. So we're going to add just a text field label with we're going to add a text field label it's going to be y equals And this is something that we're just using so that the user has an understanding of what's going on with this. Y equals we're going to do x to the exponent x to the exponent minus increment we're going to do another variable, one more edit field just to keep things simple. So starting value, the increment, the array size or number of steps that we're going to do. Intercept. So starting value, we're going to have to move this stuff down to give us a little more space for one more thing we're going to need. So we are going to need intercept. We're going to need one more of these, and it's going to be ending value. So this is the range, starting value, increment, ending value. This is the range of values that are going to be used in order to calculate our output to be plotted on the axis. So again, we're going to call this result. And we're going to jump over to code view and we're going to replace this stuff. So we need a variable. Again, we're going to keep things a little bit more constrained for this example. So we're not going to use public variables and create these properties and things yet. We'll do that in another example. But this will at least get a pretty reasonable starting point for you guys to put this into practice, because that's the whole goal. And the reason I'm trying to keep the timing of the lessons somewhat consistent is for you guys to start and stop the video, follow along, try it. If you don't try it, you're going to have a lot of difficulties in terms of getting the assignments complete, because you're not going to understand the concepts. So put it into practice, put it into use, make it happen. So our starting value, increment, ending value, we're going to do a for loop. So we're going to not use really most of this stuff. We're going to get rid of it, but we're just going to start writing where we need to here. So we're going to do start a for loop. We're going to end that for loop. We're going to say for, and the values, we're going to get those. So this is why I sometimes will leave it for myself. I'll leave some of this here as a reference point. So we want to get our start equals app dot and I need to edit, yeah, so starting value, I need to do app dot starting value, numeric value dot value to get the value, start increment equal app dot increment edit field dot value, and our ending equal app dot. It won't let you reuse something like end, so you can't store a value to end because end is already defined in the base code. So ending value edit field dot value. So these three now let us set up the for loop from start by increment. So from start by increment to ending. So for this set of conditions, do this stuff. That's what we're doing. So for this set of conditions, do this math, and then step out of that for loop. Start stepping by increment. And I'm going to put these in parentheses because that'll be cleaner. Start to, as long as start is spelled the same, that should be okay. All right, so start by increment to ending. This becomes this thing. So we're going to get what we're looking for here. This, yes, we're doing starting, ending. So those values are going to be pulled in. So for these numbers, we're also going to set up a couple empty arrays. Y equal empty array X equal empty array. Okay. You can, like in Arduino, you can kind of compact some of these on the same line at times. There are certain times where that is useful. So then you plug in the equation to build out the array where y at this is for we're gonna do simply I for the index. I is start to ending for this. We're gonna use y at I. Yeah, parentheses not needed for a for statement. So for I equal as the index, we're going to use I to count up. We're going to store to that the first value for X is going to be the index value I, because we're plugging that into the formula to calculate Y. It's going to be I raised to the one more thing we're going to need is the exponent is app dot exponent slider dot value, and this exponent, make sure it's spelled the same, I to the exponent plus, do we say plus or minus? Let's go back and look. Minus intercept. Minus intercept. suppress that output. So each time we're going to be building based on the value of I put in for X. We're already doing the substitution in there. Minus the intercept, we need the intercept is app dot intercept field dot value. Okay. Intercept field value. Here we go. And we've got our key components for the calculation. So y at I, and really for this, we don't actually need X because we're doing a substitution. So it's unnecessary code, unnecessary memory use. All right. So for each of these, and there's one more, and we do I plus plus, and I think we can do increment options. I want to see because it's an operator, but not for increment. Okay, that's there is an increment. I just can't remember. It's not the unary plus. There is an increment. Yeah, it's also under indexing. Indexing operators. Oh yeah, no, it's not. Okay. So we're gonna do the other simple other method. I equal I plus 1. Increment. All right, I equal I plus 1. Plus increment. I'm going to check this. I'm going to check this output because I think that's actually incorrect. Needs to be increment that it's going up by. This might be unnecessary. That might be unnecessary. Again, because of all the different things across all the different languages. Yeah, no, not necessary. Okay, that's what I'm in other areas you have to increment. In MATLAB, it's smart enough to understand you don't have to increment I. So this is really all we need it to do inside the for loop. And then when we're done, we are going to, so it's going to fill out I. It is going to, actually we do need X, and that's why I did that. But sometimes what does he say in the Grints? Epum sup finch, something like that. Clearly made up nonsense. It's almost like he's a real politician. I'll leave that where it lies. Building x at I equal I value. Suppress that output. Now we need to simply plot. However, to get the plot, let's set that out because we're going to do something similar to this. We're going to do a similar concept here, but we're actually going to do a plotting operation. So let me get that part of it set up real quick so that we don't spend lots of extra time while I pull together the elements. That's why these are so choppy. All right, so to finish this off, I'm actually not going to use plot for this one because the way that I want to represent the data that's going to make more sense is going to be the scatter function. So scatter is like plot, but is better for this kind of data to display a simple example of a function. So app.UI axes is what the plot is named. So you'll see app.UI axes. That's the only thing in the right panel. So that's what we're accessing, and we're telling it on that, put a scatter plot to this plot named app.UI axes. So you're taking the thing, doing an operation to the object, and storing data to it in the form of X and Y. Using the help for plot and things like that, you can do a couple other things, but it's the same kind of format for scatter. So this is a scatter plot, scatter X and Y, scatter to a name X and Y. You can also store that to a variable. So a lot of useful things that you can do with this. Gives you example of syntax. For what we're looking at, this is a little bit more useful. So when we go to run this, what we end up with is, comes up. So we could do a starting value of 2, increment to 10 with a 0 intercept and a 0 exponent. And in this case, you have to do a non-zero because reasons to make this cooperate. So exponent and the intercept. I think for this particular error, we'll go back to this. I think for this particular error, we're going to we got to start at 1, even if we have a 0 exponent, and that'll give us a straight line. So if we plot the logarithmic behavior versus the linear behavior versus the exponential behavior, it's a little hard to see. So you extend out your values maybe by 2s or something like that, plot the results. You can see a little better what it's doing. So at 1, you're linear, below 1, you're logarithmic, and that makes sense. At 0, the more aggressive, or the closer to 1 you are, the closer you are to linear. Once you get to 0, you get to a straight line at the intercept, which makes sense. So there we are. As it goes through the cycles, it adds 1 to that, so it starts at 0 and jumps to 1 and then stays there. So this becomes a step function at that point. So this covers at least the fundamentals for how to get a pretty basic GUI set up, and this will help kind of orient you guys on what needs to happen so that you can get through what you need to in order to make some serious progress on some of the scripts and things that you're going to be working on for designing a graphic user interface to solve problems. In this case, we're just showing examples of how to start doing math and incorporate functions and build them into arrays of data to be able to plot. And that becomes one of the powerful things that MATLAB can do for you. So hopefully this is insightful. Now the rest of the time, again, is you guys putting this into practice and making sure that you're doing the work so that you can replicate this and do it repeatably and reliably. So that's what I want you guys to go work on.